Today's talk is about the role of ventilation. So I'm sort of posing a question: can ventilation help to make buildings safer with regard to COVID-19? And I'm subtitling it, "Is this another ventilation challenge for the hospitality industry?" It should become evident fairly quickly why I'm putting that context on the talk. So I plan to run through some slides fairly quickly, and then open up for questions. Right, reluctance of my slides to progress. So a slight pause there. So starting point. Perhaps I should mention there is guidance that's been published by CIBSE, the Chartered Institution of Building Services Engineers, which is where I work. They're on version 5 at the moment, so they got something out fairly quickly, and then they've sort of updated it subsequently. We're on version 5. And the advice, just a few bullet points. Starting point is understand the ventilation system, understand where there may be poorly ventilated spaces or areas, increase ventilation rates as much as reasonably possible without compromising thermal comfort, avoid recirculation or transfer of air from one room to another unless there's no other way of providing sufficient ventilation rate. And of course, most toilets in commercial buildings extract air from the rest of the building to get the exchange rates required for the toilets, but that's one of those exceptions. Recirculation of air within a single room only acceptable when it's combined with a supply of outside air. Of course, if there is no outside air, it's not a ventilation system. So quick summary of the CIBSE advice. Looks very good at first inspection, but there's one or two very broad statements there that understand the ventilation system. The cynical person might say that not many people understand the ventilation systems in their buildings, or understand where there may be poorly ventilated spaces or areas. Because of course, unless the ventilation is really bad, it's not so obvious as if the lights aren't working or if the heating's not working. More on that, no doubt, as we progress. So the first thing is we need to understand ventilation. As I've already hinted, that's a bit of a tall order, and I've got a bit of history which suggests that a lot of people think they've got ventilation when they haven't. So before working at CIBSE, I worked at the University of Glamorgan. I conducted a PhD there, and in the course of doing that, I was working at the laboratories at BEng, looking at developing displacement ventilation that could manage larger cooling loads, 50 watts per square meter, which was roughly twice what was considered normal at the time. And I was looking at increasing the flow rate, the M in the MCP delta T cooling capacity equation rather than the delta T. That was already at the limit. And of course, if you increase the flow rate to get more cooling, you're also increasing the ventilation rate if that is coming from outside. And that would turn out to be significant later on. So I should also report this important disclaimer. I do work at CIBSE now. I'm not involved with the publication of their guidance. I'm on the certification side of the business. So this webinar presents a personal view based on work carried out before working at CIBSE. It's not endorsed by CIBSE or representing the views of the CIBSE community in any way. And worse than that, that's quite a big disclaimer, I do not claim to have the answers. best, I hope, to stimulate debate and perhaps suggest the right questions. The basis of all good research is knowing the right questions to ask. So if we can sort out the questions, then I can leave you to discover the right answers, which is what I was always trying to do when I worked in higher education. So whilst acknowledging that CIBSE have published this guidance, we probably need to cover a few of the basics just so we can tick that first box about understanding the ventilation system. So we talk about fresh air supply when we talk about ventilating buildings, and the amount of fresh air that's required really to dilute contaminants in the space is a direct function of how effective the ventilation is, or ventilation effectiveness, which you don't hear discussed very often. The effectiveness of most ventilation systems in buildings, because most ventilation systems use dilution or mixing, typically between 0.4 and 0.8. So 1 would be the optimum for mixing ventilation. If you could get perfect mixing, the incoming fresh air mixing perfectly with the air that's already in the room before any air moves out of the space, you'd have an effectiveness of 1. So 0.8 means some of the fresh air coming in, 20% coming in, is leaving without doing very much. 0.4 means 60% of what's coming in is leaving without doing very much. So never mind air quality, from an energy point of view, that's fairly criminal, particularly the way energy prices are at the moment. And if the air is being used for heating or cooling as well, that's wasting energy also. So to put it in the sort of terminology that people would normally use when they're talking about fresh air requirements, if you look up CIBSE guidance or building regs to find out how much fresh air you need, 10 litres per second per person is a fairly typical figure for offices. So 0.8 effectiveness means you're actually getting 8 litres per second to the people. If it was perfectly mixed, you'd only need 8 litres a second, but we provide 10 because the effectiveness is 0.8. I've surveyed buildings looking at this particular problem, and I found short circuiting, that's where the air can come into the room and leave before it does anything, was so bad that I'd be surprised if the effectiveness was as good as 0.2. There's a very practical reason why this is so commonplace, even though it's undesirable. We quite often supply air through grills in the ceiling and extract air through grills in the ceiling because it's convenient, from an integration point of view to do that. There's a space above the ceiling for the ductwork. But if you're going to supply and extract through the ceiling, you've actually got to be very careful to make sure you don't get short-circuiting, the air coming in, going across the ceiling and out again without touching the people below. And it's very commonly done badly, so that there is a lot of short-circuiting. And people get away with it because, as I've already said, it's not obvious the ventilation isn't being very effective until you start worrying about things like COVID. So the term to describe what I've been talking about is room air distribution. You want to design the room air distribution to make sure the incoming air mixes fully before it finds its way to an extract point. The sort of science behind this was published and sort of well established back in the 1950s, before most of us were born. So it's nothing very new. Anyone who studied building services engineering at London South Bank, as I did, will be familiar with this work, and I won't be able to resist the temptation to use it in the slides. It appears in lots of engineering services guidance documents published since 1957, so it's frequently recycled. It is nothing new, but for the practical reasons I've described, we do seem to struggle with it very often. So what they were doing in labs back in the 1950s was doing flow visualization using smoke and then converting it into little pictures like this. So you could develop the room air pattern in theory before it gets installed and work out where there might be stagnant areas and make sure you avoid those and make sure you don't get air coming in and going straight out again. So in these diagrams, the air's coming in bottom left and leaving bottom right, which isn't very common. So how do we solve the problems I've been talking about? What are the basics of good room air distribution? Well, position your supply and extracts to avoid short circuiting. Don't blow the air straight towards the extracts across the ceiling. Stir the air without causing discomfort. So that means design the supply grills with vanes to make sure you get a decent velocity with the air coming in to get a stirring effect, but do it without blowing it straight down people's necks and causing discomfort. So it's avoiding that second one, going down people's neck, that people tend to deflect it across the ceiling, which creates the first problem. So you can't please all people all the time, clearly. And that's it, actually. If you're expecting a long list, something that's such a problem that people struggle to get right, that's it. I guess it's a problem because the two in practice tend to be contradictory. So one other thing to note is that this standard ventilation approach, the idea of mixing up what's in the room to mix in fresh air and dilute whatever it is you're worried about in the room. The idea is that you're trying to dilute contaminants to an acceptable level. You're not removing them completely. You're just continually diluting. If you want to actually remove them completely, you need to think about using displacement ventilation. As the name suggests, you're actually moving stuff out of the room and replacing it with fresh air and avoiding mixing. So that's what the decay graph looks like. That's whatever contaminant you might want to pick. So in places where there's people, you normally monitor CO2. The rate at which it falls, so this curve falling from left to right, depends on ventilation rate. So the higher the ventilation rate, the less time required to get down to a low level, is what that's telling you. It's fairly common sense, actually, but there is some maths behind it. So what's the link between COVID-19 and the work that I was doing with the hospitality industry in the past? Well, originally I got asked to do a desk study because the ventilation industry were interested in whether the hospitality industry were interested in whether the ventilation industry could deliver effective ventilation systems, which you'd think would be a no-brainer, but they were aware of some criticism of ventilation systems. Their starting point was to make sure there was a supply industry that could deliver. They were mounting a bit of a rearguard action. They saw an impending smoking ban as having a negative effect on their business, and they were trying to persuade the government that a compromised position would be to ventilate buildings well enough to dilute the smoke to a low enough level not to be a problem. And they were being told by the anti-smoking lobby that ventilation doesn't work. And when they came to me with that proposition, there were people out there saying that ventilation doesn't work. Can you help us convince them otherwise? I thought that was a reasonable question to ask. So later on, I was asked to test the effectiveness of a ventilation system installed in a pub with a specific objective of protecting the brewery staff from secondhand smoke. It was a pub run by the brewery, and they wanted to protect their staff from the secondhand smoke from customers. It's a bit of a history lesson today, isn't it? Can you remember when people could smoke in public places? It's a while ago now. It was controversial at the time. I was working with the bad guys, people who were getting in the way of the medical profession, trying to discourage people from smoking. So my position on smoking, I was put off the idea of smoking when I was at school. We had this poster on the school notice board, and I've never smoked. So that worked on me, but it didn't work on a lot of people. So we ended up with the campaign to discourage smokers by stopping them smoking in their favourite place, the pub, allegedly. So sections of the medical profession, understandably frustrated, they couldn't persuade people to stop smoking, so they were lobbying hard to ban smoking in public places. But my concern was that ventilation was getting a bad press, to make sure that smoking ban was the only option. And it's difficult enough, as I've already alluded to get people to ventilate their buildings properly in the first place. Without politicians and scientists saying it doesn't work. So I thought I should do a bit of work to show that it does. I worked for the NHS for 8 years, and every day before operating theatres go into use, you have to demonstrate the ventilation system is effective. They rely on it very heavily for infection control in operating theatres. So, you know, I know it does work. Of the devolved governments in the UK, only one of them acknowledged that ventilation could help, but they didn't back it because they had concerns about policing it. In other words, you could show it worked today, but what about tomorrow and the next day and the day after? You'd need some sort of inspection regime, which is exactly what we're looking at in the COVID context now. This was a quote: ventilation can control other contaminants, but it doesn't work on tobacco smoke, which in the cold light of day is ridiculous. I won't try and attribute it to an individual, but it was the sort of thing that was being said. There's something called Dalton's law of partial pressures, which means that if you've got a mixture of gases and you dilute it, the amount you dilute one applies to all of them. You know, you can't single out and deal with one thing and not with another. I did get quite involved with on-site testing and subsequently in developing solutions in the UK and in mainland Europe. And there wasn't much of that being done at the time, which made me an expert. I got involved in some expert witness work as a result. So why was it a problem? If pubs were ventilating, why did they have this bad press? So they had the idea it would be a good idea to segregate smokers from non-smokers, maybe have smoking areas and non-smoking areas. And they also thought they could do this cheaply with through-the-wall extractor fans. You cannot influence the movement of airborne contaminants with an extract fan. Basic room air distribution again. I was talking a few slides back about supply and extract points. The problem with webinars is they're not really very interactive, but I will risk trying to do a live experiment. Can I ask everyone to grab a piece of paper, anything you've got handy, and just tear a little strip off it, 25 mil or an inch wide, perhaps, and 150 mil long or longer. What's the side of A4? So I'll just pause while you do that. So everyone's holding a strip of paper. I'd like you to hold it out at arm's length and simulate a supply grill by blowing air towards the strip of paper. I'm anticipating that the paper will move away from you. So if we've successfully done the first part, I'll now ask you to simulate an extract grill and suck air towards you. Suck as hard as you can, and my prediction is the paper won't move. So try bringing it a bit nearer, and you'll perhaps be surprised by how close you've got to bring it to your mouth before you can actually influence it. So I hope I haven't worn you all out doing that. That's why room air distribution is important. You influence where the air goes with a supply grill. You have to put the extract grills where you think the air is going to end up. The extract grills won't pull air towards that point, whether it's smoke or airborne viruses, same rule applies. So a strategy relying on extract fans wasn't very effective. It was diluting the air in the room, but it wasn't doing anything to stop the air in the room being fully contaminated by smoke. It wasn't drawing it away from a no smoking area, for example. It would fully occupy the room and eventually find its way to the extract point. So that's why they had a problem. They'd really lost the argument before they started, because relying on extract fans meant that people were going into so-called ventilated spaces and they were actually smoky. So that's why they had the problem. Clearly, ventilation didn't work. So just to be clear, dilution ventilation won't completely clear the contaminant, but the higher the ventilation rate and the greater the effectiveness, the quicker the contaminant will be diluted. So if we're trying to deal with airborne viruses, increasing the ventilation rate helps, and that is the SIBSE guidance. But actually, for that ventilation rate to really work, you need to make sure your ventilation effectiveness is good as well. This does require a lot of attention during installation. So is there a better way than dilution ventilation, this decay thing, which never actually goes to zero? I think I mentioned displacement ventilation, and I'm not going to assume that you know the difference, but mix of ventilation on the right, have a quick look at it. Air blown in and stirred up, as I mentioned earlier. So the shading there is uniform throughout the room. The level of contaminant in the room is the same wherever you measure it. Displacement ventilation involves blowing the air in gently at low level, not stirring it up, allowing the air to just drift across the room. You blow it in slightly cooler, so there's no tendency to rise with natural buoyancy. So it fills a room the way water fills a bath, and then gets pushed up, taking contaminants, heat from equipment, what people are breathing out, up to the top, and that's where it's extracted. So there's no short circuiting, and you get very effective ventilation. Not always easy to do in practice, but worth aspiring to. So done correctly, ventilation effectiveness can actually be better than 1. And therefore you'll get a particular level of contaminant control with a lower ventilation rate and lower energy use compared to dilution. And it's also difficult to get room air distribution wrong with displacement ventilation. It just, as I said, fills the room like water fills a bath. So you only need one supply point on one side of the room, and the fresh air will get everywhere you want it to before it starts mixing with what's in the room, or rather pushing out what's in the room. It doesn't mix. So we were trying to get this to work in pubs as part of the smoking project. And the same logic will apply for COVID. So I'm hoping you're already making the connection when I started this journey talking about smoking, but now we're talking about COVID. If you haven't made the connection, the government certainly have. I don't know whether you've seen adverts like this in the press and on television. They're saying that COVID-19 gathers just like smoke, and open windows to disperse the particles. Well, opening windows is a form of ventilation. It's not very controlled though, and just to put it in context, if 12 or so years ago, I'd been saying, maybe 10 years, saying to governments, you don't need to ban smoking, just get the pubs to open their windows. I think I'd have been laughed out of the room. But that's what advice we're getting on COVID now, open the windows. It's better than not opening the windows, but it's not a substitute for having a good ventilation system. So time to revisit the PhD. It was a bit more complicated than this, but I did demonstrate that by using fabric diffusers as the supply diffuser, you could get higher flow rates than previously thought without causing draft discomfort. That's the tricky bit, getting more air into the room without causing drafts. So one of the project co-sponsors was Hawley and Partners. They had oversight of the findings. At the time they were tasked with designing ventilation for a restaurant for a tobacco company's head office. Using the ASHRAE, that's the American equivalent to CIBSE, their recommended air change rate was 60 air changes an hour if you had smokers in the room. And they were having trouble getting that air change rate without causing drafts. So they tried what I developed and it worked very well. And they kindly allowed me to use that as a case study in my PhD, which was significantly helpful in a successful outcome. So this was the restaurant. The air supply is through those white columns down to the grills at sort of waist height down to floor level. So the air's coming in at low level, cascading across the floor. And you did have a situation where people sat at one table wouldn't be aware that people on the next table were smoking because everything was going upwards, not horizontally. And that's the same technique used in a meeting room. Again, the grills around the walls at low level. The grills are for aesthetic purposes. Behind that, there's a fabric diffuser. So we, without the cosmetic grills, this is what the diffusers look like. These were positioned behind the bar with the idea to drop the fresh air. It would just fall vertically across the optics there, down to floor level behind the bar, and then spill out over the counter, keeping the customer smoke at bay. Well, we know how that campaign ended. We had a smoking ban. But does it give us any pointers with dealing with COVID? Well, it was working. I say it was the concerns about policing it, and that is now on the agenda for dealing with COVID. I said I wouldn't be offering answers, but question, would a high volume displacement system present a lower risk of the horizontal spread of airborne viruses where people are eating and drinking? I think it probably would. What about elsewhere? Theatres, cinemas, places where people aren't moving around much is where displacement ventilation works best, which is why I say theatres or cinemas. Bingo halls, lots of people sat around in bingo halls, but healthcare premises, waiting rooms, places like that. That's, I think, historically is where what put some people off going to the doctor, sitting in a waiting room with other ill people. What are you going to catch while you're sat in the waiting room? Displacement ventilation there would probably be very helpful. How could it be demonstrated or quantified? Well, people are putting their minds to that at the moment. I did speak to Nick Cullen at Hawley and Partners to make sure he was happy about getting a name check in these presentations, and he was. Interestingly, he said that early on he was in conversations with NHS staff, and they were more concerned about contagion than airborne transmission. But the adverts I've just been referring to suggest that thinking has moved on a bit with that, and I think airborne transmission is a serious concern. Could it be policed? Well, since we abandoned the idea of using ventilation where people are smoking, there has been legislation requiring air conditioning systems to be regularly inspected for energy reasons, but there is a workforce there to do that, and that could easily be expanded to deal with ventilation performance. That is something that I'm involved in with my job at CIBSE. So I think the answer to that is probably yes, if you're really keen to do this. Just a couple of slides now to finish off. This is the occupational health and safety hierarchy of controls. General principles dealing with hazardous substances. So just to put the smoking back in the frame, we dealt with that by eliminating the hazard. If you don't let people smoke in the building, you don't have to worry. So everything below that level of control isn't required. If you can do the top thing, you don't need the rest. If you can do the second thing, you don't need the rest. Ventilation comes under the third, engineering controls. So with smoking, you could remove it at the top. With COVID, that's what we did originally, wasn't it? We had lockdowns. We said you can't meet in places. You can't use restaurants. You can't use pubs. You can't have birthday parties. Well, I'll steer away from controversial topics, controversial enough in the first place. But yes, if you can't eliminate the hazard, if it's not acceptable to keep everyone locked down forever, then engineering controls becomes a lot more important. And that's where we are in this hierarchy. If we can get engineering controls to work, if we can ventilate spaces effectively, then you don't have to worry about PPE, which is the last resort. Supplementary COVID advice. I've mentioned CIBSE advice, but there are other people offering advice. We've got the CIBSE version 5 now. Just spend a bit of time on that before we finish. I've been a bit critical of that guidance because it talks about increasing ventilation rates but not improving effectiveness. It might be that they thought there's not much you can do about it in an existing building. I've said it's important to consider it at design stage, but actually once it's there, you can look at how the supply diffusers are orientated. You might be able to adjust vanes to help, or you could simply close off some of the extract points where supply is short-circuiting to. You don't need all the extract points. We typically oversupply extract points just for aesthetic reasons. You know, there's a uniform grid in the ceiling, but we could close some of them off and not spoil the aesthetics. You could do it behind the grille. And the guidance makes no mention of displacement ventilation, which I think is the optimum solution. A bit more challenging, but achievable in many buildings. The guidance also talks about chilled beams. Very often used with displacement ventilation to give you some additional cooling, but they do cause air to fall from ceiling level to floor level, which is the complete opposite of displacement ventilation. So I don't think they should ever be used together, not just in the COVID context. So the downward convection is much stronger than you might think. So I've got some old images from the labs where I was doing my work. These smoke plumes are used to visualize where the air is going in a room, and the smoke is being introduced in the suspended ceiling behind a chilled beam, and it's reaching the floor. There's no fan involved. That is just because that air is a bit cooler, because the chilled beam is cooling it. There's another one. You can see that's hitting the floor with such momentum that it's turning up again, because it's like an inverted mushroom shape. So if you've just used the displacement ventilation to get all of the contaminant up into the ceiling, you don't want to put a chilled beam on and bring it all back down again. So do we think that customers would be reassured to know that a restaurant has personalized ventilation? I think so, but you could substitute several other types of area instead of restaurant. If you could do that, do we think that could allow pubs and restaurants and other buildings to stay open if we have restrictions again? We're in a bit of a purple patch at the moment. We're living fairly freely, but if you look at what's happened in China at the moment, there's no guarantee we won't end up having to worry about restrictions again at some point. So yeah, the question posing at the end there, I was working in hospitality. Are there other applications? I've mentioned a couple, maybe you could think of others. I said we were approaching a final slide, but anticipating a question, I've been asked this quite a lot, what about UV filtration units? There is a lot of work being done to confirm the effectiveness of UV. I mean, UV can be used to kill the virus, but again, it's an operational concern. Can it be maintained effectively over time? But the CIBSE guide does mention this. It does say they can be used. If you can put them somewhere in the room where there's effective mixing, and as I've already suggested, that might be a challenge. But if you can put it somewhere in the room, it might actually help with the mixing, to be fair. So they probably do have a role to play, but the main concern there is about the ongoing effectiveness and the need to keep them clean and when you need to change the lamps and so on. I mentioned CIBSE as a source, the British Occupational Hygiene Society. I haven't put the link there, but if you Google them, you'll find they've published quite a lot of guidance on managing the COVID risk as well, including with reference to ventilation. So there we are. If anyone's got any questions, happy to take questions now.
Thank you, Andrew. Yes, if anyone's got any questions, if you just type them in the Q&A box that you have, and I'll pass those questions on. How do we keep low carbon in balance with increased ventilation effectiveness?
I think the answer to the question is in the question. Maybe you meant how do we keep carbon in balance with increasing ventilation rates, which is the headline guidance. The answer to which would be to improve the ventilation effectiveness so you don't need so much fresh air. So just to refer back to the figures, you know, if you've got a ventilation effectiveness of 1 and you want to get 10 litres a second into the room, you supply 10 litres a second. If you've got a ventilation effectiveness of 0.5 and you want the benefit in the room to be as if you had 10 litres per second, you'd actually have to supply 20 to get the effect of 10. If the effectiveness was 0.5, it's as literal as that. So conversely, if you get an effectiveness of 2, which you could do with a good displacement ventilation system, instead of 10, you'd need 5. So that's how you keep the carbon in balance. Use a more effective ventilation technique so you can actually reduce the amount of air that you're moving and the amount of air that needs tempering. So increasing the ventilation rate is the published advice, but you can achieve the same effect with the same, keep the amount of air the same, but improve the effectiveness.
Thank you again, Professor Geens, and we'll look forward to seeing everyone else on a future KES Talks. And I'd like to say thanks for today and good afternoon to everybody.